All right, today's lesson is going to be on the distance formula. So here's our notes template. If you don't have the notes template, you can just do it on regular notebook paper. That is totally fine. But go ahead and write topic at the top or fill in the notes template as I'm going to do here. And we're going to be talking about the distance formula. All right, so what is the distance formula? Well, we're going to look at that in just a second, but first let's talk about the objective. What is it that we're hoping to learn from this lesson? Well, what we're hoping to learn is the relationship. What is the relationship? What is the relationship between the distance formula and the Pythagorean theorem? And Pythagorean, I'm just going to abbreviate it there, Pythagorean theorem. All right, so what we're hoping to accomplish is that we will understand relationship between the distance formula and the Pythagorean theorem by the time we are done. All right, so first let's look at the distance formula and what it is. Okay, the distance formula looks something like this. It equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, it's a formula we use when we want to find the distance between 2 points on a coordinate axis. So what I have here, I already have a coordinate axis drawn down here. And so what happens if we have 2 points somewhere within this plane? Okay, so this would be our x-axis over here. This would be our y-axis. And we have 2 points somewhere in the plane. So we have 1 point over here somewhere. We have 1 point over here somewhere. Where the points are don't matter. The points could be anywhere as long as you have 2 points. And what the distance formula gives us is literally the distance between these 2 points. And so that's pretty useful to know the distance between 2 points. All right, and so the question is, what do we plug into this formula? Well, in order to identify a point on the coordinate axes, we need to have an x value and a y value. And so we call it x1 and y1. Here's another point. We'll call it x2 and y2. And the reason why we use these subscripts 2 and 1 is to keep them separate from each other. And the reason why we don't use numbers is because we want it to be true for any 2 points. So x subscript 1 and y subscript 1 would represent 1 point anywhere on this plane. X subscript 2, y subscript 2 would represent another point anywhere on this plane. But this point is different than this point, because those points are not the same. All right, so now if you want to just plug into that distance formula, you would need 2 specific points. But let's go ahead and look at where the distance formula comes from first. So where the distance formula comes from is we could create a triangle if we want, and that triangle will look something like this. All right, we have a leg here, and we have a leg here. And that triangle, trying to draw straight lines, I get a straight line drawing tool, but that's okay. On your paper, you don't necessarily have straight lines either. I can make a triangle out of this using this line. I can use this line that connects these 2 points and think of it as the hypotenuse of a right triangle. Okay, and so I can make a straight line going over, a completely horizontal line, and then I can make a line that goes completely up from there, a completely vertical line. And so where the vertical line meets the horizontal line would be the vertex of that right triangle, and that's where the right angle would be. And the reason why that's advantageous is because now we can think of this as a right triangle, and we can think of the hypotenuse as our C. And so this is the C of the right triangle. And then this is a leg here, we'll call A, and this is a leg here, we'll call B. And so the question is, how long is A and how long is B? Because we know the relationship between A, B, and C. The relationship between A, B, and C is A squared plus B squared is equal to C squared. Okay, that's relationship. So now the question is, what is A? So A has a certain length to it. That length goes from x1 over here to x2. So it's the difference between x2 and x1. That's the length of A. So I could write A as x2 minus x1. And what that means is whatever the x value is of this point here, going to cross the x-axis somewhere. And whatever the x2 value is here, it's going to cross x-axis somewhere. But the distance between here and here is going to be the length of A. In a similar way, B, the other leg of this right triangle, is going to be the difference between y2, which is going to be somewhere on this y-axis, y2, and y1, which is going to be right here. So the difference between here and here is also the difference between here and here and the length of B. So it's y2 minus y1. All right, so now all we have to do is plug these values in for A and B. They're not really values. Plug in this relationship for A and relationship for B into the Pythagorean theorem. And we get for A, we get x2 minus x1. For B, we get y2 minus y1. Let me work on my parentheses there. And C stays the same because that's what we're looking for. C is the distance. All right, and if we want to find C, which is the distance, and we want to find that by itself, to get C by itself, we have to undo the fact that it's squared. And to undo that, we have to take its square root. So if we take the square root of C squared, and then whatever we do to one side, we have to do the other side. So on this side, we have x2 minus x1 squared plus y2 minus y1 squared. And over here, we're going to have the square root of C squared, which is the same thing as C. And I'll just rewrite C over here. And so basically, that is our distance formula. You look up at the top, there's your distance formula. And it comes from the Pythagorean theorem. So the distance formula is nothing other than the Pythagorean theorem. Sorry if my X is a little messy there. I don't know if they helped that or not. But anyway, x2 minus x1 squared minus y2 minus y1 squared. All right, let's look at a quick example of how to use the distance formula. Let's say we have 2 points on our axes. So I will go ahead and draw another axis here. So I have a line there, and I have, oopsies, that didn't work. Let's try that again. And I have another line here. Okay, there we go. And then I have, let's say, just a random point up here somewhere. We'll say it's -3, 2. And I have, and we'll call this an example. This is one of our examples for the distance formula. And then I have another random point. Oh, we'll just say it's down here, which we'll say it's -1, -5. Okay, and so here's our 2 points, and we want to know the distance between those 2 points. In other words, what is the distance right here? Okay, we want to know that distance. What is that distance? We got a big question mark there. What is that distance? Okay, so we could make another right triangle and do the Pythagorean theorem on it, identify the 2 legs, do the Pythagorean theorem on it, or we can use the distance formula. The distance formula tells us that's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And then we just have to plug in. So we have to recognize our points. So this is, it doesn't matter which one's subscript 1 and which one's subscript 2. We just have to be consistent. So maybe I should identify that ahead of time. Which one is x1, y1, and which one is x2, y2? It does not matter. And the reason why it doesn't matter, because they're squared. So even though we're subtracting, we end up squaring it. So we're just looking for a distance. Doesn't matter which one is which. So let's just randomly choose the -3, 2 as our x1, y1, and then the other one's going to be a1, -5 as our x2, y2. So our first point will be the one that's up higher, and our second point is the one that's a little lower. And you could have done it the other way. It doesn't matter. You just have to stay consistent. That's why it's good to write down which one's x1, y1, and which one's x2, y2. So your distance ends up being the square root of -1 minus -3, because -1 is x2 and -3 is x1. So I'm taking -1 minus negative 3. I know that looks like a lot of minuses in there, but it works out, just trust me. All right, and then y2, which is negative 5, minus y1, which is 2. Okay, and so it's just important to stay consistent. That's all I have to say. Make sure you stay consistent. Make sure you keep track of which one's x1, which one's y1, which one's x2, and which one's y2. And that's why it's important to probably write it out so you can keep track of that. But then after that, you don't have to worry as long as you follow the rules correctly. So negative 1 minus the negative 3 is the same thing as negative 1 plus 3. And negative 5 minus 2 is going to equal negative 7. And so we're going to end up getting square root of negative 1 plus 3 is 2. So you get 2 squared plus, and then negative 7 times negative 7 is positive 49. So it didn't matter which one came out positive, which one came out negative, because we end up squaring it. So you end up with 4 plus 49, which is equal to the square root of 53. And so if we could simplify that, that'd be great, but 53 is a prime number, so we can't simplify it. So we have our answer. All right, so that is an example of the Pythagorean theorem and how it's related to the distance formula. So hopefully you can see now the relationship between the distance formula and the Pythagorean theorem. It's basically the distance formula is the Pythagorean theorem, but we don't have to go back and do the Pythagorean theorem. We have a formula now anytime we want to find the distance between 2 points. All right, go ahead and write a summary in your notes. Summarize what you learned in your own words in a couple of sentences.